Hello everyone, this is Dmitry from Galileosky and we continue discussing geofences. During the previous video, we learned about rectangular and circular geofences that could be arranged via easy logic algorithms. This approach is useful when you have only several simple geofences in your project. Polygonal and linear geofences, on the other hand, must be described in the KML file that you need to save to the tracker's SD card or eMMC memory. You can create a KML file with geofences in your software or use the free Google Earth application for this purpose. But before we start creating our geofences file, let's discuss some specifics regarding the geofences processing by Galileosky trackers. In your KML file, you can use only polygonal and linear geofences. Circular geofences will not be recognized by the tracker. There is a limitation in 2000 points for the single geofence. At the same time, 7X devices with the firmware 44.2 and higher and all Galileosky 10 devices support KML files with up to 1 million geofences. The tracker considers geofences one by one as they go in the file in the same order. It means that in case your file contains overlapping geofences and the vehicle in this geofences overlapping area, the geofence that goes first in the file will be accepted as the active one. The linear geofence, which is also called a polyline, is considered as the 50 meters wide linear area that goes along the line in the geofences file. And now the most interesting part. All available at the market Galileosky trackers, base block iridium included, allow you to add up to 4 custom parameters to each geofence. You need to name your geofences the following way to use this feature: geofence name, colon, first parameter, semicolon, and then the rest parameters separated by semicolon without spaces. For example, in my case, the name of the geofence is GF001. Next goes colon. Next, the third parameter is 100. Then goes semicolon. The second parameter is 80. And then the pair of semicolon. Parameters 3 and 4 are empty. So now we can start by creating some geofences using the free Google Earth application and uploading the file to our Galileosky 10 tracker. I'm starting the application and searching for the necessary region. Now I'm creating the new folder for our geofences at the left side of the screen. If you want to create the polygonal geofence, use the Add Polygon button. The linear geofence is available with the Add Path button. In the additional screen, we need to set the name for the newly created geofence. Don't forget about the correct geofence naming. Done, we have our first geofence. Thanks to the magic of the cinema, we now have a small list of geofences which we can save to the file. At the left side of the screen, click on the folder with our geofences with the right button of the mouse and choose Save Place As. Find the place to save your file. Set the name as Zones and choose the file type KML. That's right, the correct name for your file with geofences must be zones.kml. Now we need to copy the file to the storage of our tracking device. As usual, we firstly need to unlock the storage by the command msd-1. Now I'm using the WinSCP file manager to create the folder geofences in my tracking device storage and copy the zones.kml file to this folder. Please pay attention to names of both the folder and the file. The file must be called zones.kml and it must be stored to the geofences folder at the SD card or eMMC memory of your tracking device. The tracker will ignore any other files or the zones.kml file placed somewhere else. It also means that all your geofences must be arranged in this zones.kml file. So now I am returning the device access to its storage by the command msd-0. If we did everything properly, the device will start processing our newly added file. The progress can be seen on the troubleshooting page if we enable the navigation data detailed mode. Once the process is done, we can see the additional system files in our geofences folder. One more important thing is that Galileosky 7X trackers with the firmware 38 and 44 and higher process geofences differently, and the cache data created on the firmware 38 will not work on the firmware 44 and higher. So, in case of such update, it will be necessary to delete all system files from the geofences folder to trigger the firmware to reprocess your geofences. You can do so locally or remotely using the command fsdelete. You can learn more about commands for managing data on SD card or eMMC memory in one of our previous tutorials. As usual, you can find the link in the description to this video. So we have our file uploaded and accepted by the tracker. Now when the vehicle is inside of one of our geofences, the corresponding flag in the device status will show it. Yet this is only the basic function of the firmware. The most interesting features are available in easy logic. On the screen you now can see a simple algorithm that notifies the driver about the overspeeding by enabling the buzzer connected to the output 0 of the tracker. After the device starts, we firstly check if the vehicle is inside of one of our geofences. Geofence global variable contains the necessary information. This global variable contains -1 when the vehicle is outside of any existing geofences. When the vehicle is inside of one of our geofences, it contains the number of the current geofence in the file starting with 1. So, in case the vehicle is outside of our geofences, the current speed is compared with the default speed limit set to 100 km per hour, and in case of overspeeding, the output 0 is enabled. When the global variable geofence is more than 0, which means that the vehicle is inside of one of our geofences, the logic compares the current speed with another global variable called geofence property 1. This variable contains the value of the first parameter of the current geofence. As you remember, I was adding values to the first and the second parameters when I was creating my geofences. In my case, the first parameter contains the speed limit for each geofence. So now, the logic automatically applies the individual speed limit for each geofence and enables the buzzer in case of overspeeding. We can work with other geofences parameters the similar way. For example, the second parameter can contain the lower speed limit that is applied at night or during the winter. The logic complexity will only slightly change for those additional conditions, but still, as you can see, the algorithm is quite simple. Speed monitoring is only one of possible applications for geofences properties, but there are many of them. For example, you can set some of your geofences as safe zones and raise the alarm in case someone accesses the cargo outside of your safe areas. You can also disable some equipment on your construction vehicles outside the construction site and prevent this way the unauthorized usage of your vehicles. So, as you can see, creating geofences is simple and the possible applications are limitless. You can always find the text manual for geofences in our base. Open the base. At the catalog on the left side of the screen, choose Device Configuration, Geofences, Polygonal Geofences. Please feel free to join our YouTube channel to always have access to our tutorials and learn about new developments. This is all for today. Dmitry was with you. See you in the next video.